Why can't astronauts keep their balance on the moon? Not only do they weigh less than on Earth, but they also have to contend with the moon's lumpy gravity. I'm Sophie, and welcome to the countdown. That's right, the gravity field of the moon is uneven. Certain regions contain unseen extra mass, which increases the gravitational pull over the denser areas. And now, NASA's Grail mission has used gravity data and computer simulations to find out how these mass concentrations, or mascons, form. Back when the moon was young, it was a lot hotter. Asteroids or comets hitting the moon during this period affected the density of the planet's crust. When you look at a gravity map, these impact points show up as a bullseye pattern. There's a central point of higher mass and greater gravity, surrounded by a ring of lower density and weaker gravity. The more we learn about the moon's mascons, the better we can understand impacts on other bodies, including Earth, Mars, and Mercury. The findings could also help spacecraft in orbit deal with lumpy gravity. But unfortunately, they probably won't keep astronauts from falling over their own feet. Curious about what a certain Mars rover has been up to lately? Let's check in. After the Curiosity rover landed in Gale Crater last year, it trundled for about 500 meters to reach Glenelg, a region smaller than a football field. And for the past 6 months, it has remained confined to this area, scooping soil and drilling for rock powder. These samples reveal Gale Crater once contained elements, energy, and water capable of supporting microbial life. Next, Curiosity will check out 3 more sites in Glenelg, which may be the remains of flowing water or volcanic activity. But after that, the rover will hit the road on a new journey. Over the upcoming months, it will travel about 8 kilometers towards Mount Sharp. Any interesting features Curiosity meets along the way could lead to new discoveries. And once the rover arrives at Mount Sharp, it will have access to rock layers that may provide a glimpse deep into Martian history. According to the current model of the universe's formation, lots of dwarf galaxies should surround our own Milky Way. Unfortunately, scientists hadn't found any, which hinted at a serious problem with the model. Now, we finally discovered one of the predicted galaxies, and it's the lightest one ever observed. Seg 2 is a dwarf galaxy with roughly 1,000 stars. These add up to a brightness about 900 times greater than our Sun. This doesn't sound too shabby, but it's incredibly weak for a galaxy. The Milky Way is about 20 billion times brighter. With its dimness and low star population, Seg 2 might be mistaken for a mere star cluster. But the dollop of dark matter holding its stars together elevates it to galaxy status. By studying Seg 2, scientists hope to learn more about how galaxies formed in the young universe. Want to explore space from the comfort of your own home? Zooniverse, a website that collects citizen science experiments, is asking human volunteers to search for gravitational lenses in a project called Space Warps. To find these objects, participants will pore over telescope images for signs of lensing, which a computer algorithm may have missed. As you can see in this recent SciAm video, gravitational lensing occurs when a chunk of mass is sitting between you and the distant object you want to see. The gravity of this mass distorts the light from the source into a characteristic ring or arc. This distorted background allows astronomers to calculate the mass of the lensing object, which helps them map dark matter. And gravitational lenses can also magnify objects, revealing distant galaxies in detail. You can volunteer for duty at spacewarps.org.
The sun and you and me and all the stars that we can see are moving at a million miles a day.
In an outer spiral arm at 40,000 miles an hour of the galaxy we call the Milky Way. Actually, Eric Idle from Monty Python's Meaning of Life, the sun and most of the stars around us are zipping through the galaxy at more like 220 kilometers per second. Impressive, but compared to a hypervelocity star, our sun is crawling. Hypervelocity stars travel 3 times faster than we do, which allows them to escape the gravitational shackles of the Milky Way and strike out on their own. But how do they pick up their extraordinary speed? According to current models, the hypervelocity star starts out in a binary system. A force disrupts the system, which sends one of the stars hurtling off into space. Some scientists think the disrupting force could be the black hole at the center of our galaxy. And in a new study, researchers used computer models to test a second hypothesis, which says the disrupting force could be a supernova. The models proved that 93% of the time, a supernova explosion could indeed produce a hypervelocity star from a binary system, giving it a 4 to 25% chance of leaving the galaxy. But the theory can't explain the fastest known hypervelocity stars, which means there could be more than one way of turning a star into a speedster. And that's your countdown. Links to all of these stories are in the description below. Also, don't forget to visit the Space Lab channel on YouTube and subscribe. For Scientific American, I'm Sophie Bushwick. Until next time, I'll be searching for gravity lumps.